Alright, here's the next setup for the ship's wheel here, and see what kind of trouble we can get into this setup here. This is kind of a suboptimal setup here. Let's shade that a little bit so you guys get a look. And listen guys, I've played around with white balance and polarizing filters and shades and all kinds of stuff, and it's too much work. It doesn't work, just so you guys can see the indicator, okay? Anyway, what we're going to do is we want to take a little bit off of the rim of this to true it up. I don't know if you can see that bouncing around a little bit there. We bored the ID, and so that's kind of our true surface, and we have our bolt pattern. So, you know, it's just kind of, it would be nice if that was trued up and straight. We're going to give it a try and see if it works. What I'm worried about in this situation is that it's going to chatter because listen. See, it kind of just wants to ring on its own. So I'm thinking what's going to happen is it's going to ring when I try to cut it. But we're going to try it and see how it works. Okay. So let's get this out of the way, and then we'll get our cutting tool set up. All right. So we got everything loosened up here, so we can move things around. Now, what I'm going to use here, if you can see it there. So this is basically kind of a positive geometry tool here. And the reason to use something like that, although this is technically a negative insert, the way the chip breaker is designed on this particular thing, this insert, it gives us a positive cutting geometry. And the reason for that is very low cutting pressure, okay? If we use a negative type insert, okay, like one of Adam's favorites, CNMG here, right, which is a really great insert. You get good finishes, but the cutting forces are higher. And when you have a dicey setup like this, and this is, yes, a dicey setup, positive geometry kind of is your friend, okay? So let's swivel around here. So we're going to put the compound at 90, and let's see, what do I want to do here? Actually, you know what? I'm going to go a little more than 90. Actually, you know what? That's not going to matter. I think I want... Yeah, I'm just going to put it straight, actually, but I'm going to shift it off here. That should get us where we want to go there. You know what? I'm going to try to tip it like that a little bit. Get a little bit of room. All right, so let's snug this down, and let's take a test cut and see what we can do. All right, so I think we're ready. We're going to spin this pretty slow here, as you'll see. Let's kind of get up close. All right, so touch off here, and I'm going to add one more thing while I'm thinking about it. And that is, we're just going to put a little pressure disc against that, just because we can. All right. And this is just a disc to put a little additional pressure on the whole setup there. All right. It ain't gonna hurt. Let's put it that way, okay? Make sure that's tight. Okay. Let's give it a spin. Pretty happy. All right, let's well, that's actually encouraging that it's not ringing right out of the gate. All right, let me back up. Let's give it a little depth. This is going to be really boring, slow feed. And actually, I'm becoming encouraged here. I may be able to speed this up considerably. So We'll see once he gets in there though. Okay, so we went from 32 RPM to 82 RPM. Let's see how this works. Oh yeah, no problem. Well, that'll take a lot less time. Now I use the mini pallet clamps here to clamp it to this sub plate that goes in the lathe, and you know, I just kind of eyeball centered it on that the sub plate, and then I dialed in the bore, the part that I care about. So you can see, if you look through the spokes, the sub plate's wagging around in there, but we don't really care about that because the disc is spinning true. Hope that makes sense. We're at 112 RPM, which at this diameter is over 300 feet per minute. Take another 15 thou off here. It's behaving itself fine. Let's try this new speed. See what we get. Yeah, call that fine. Alright, so it looks like we cleaned up around the outside. Let's get that out of there. And let's, some of these are going to need re-countersinking, so we're going to use our Deburring again. And that's really just to break that edge. Alright, I got a little burr on that. There's enough side run out in this, so I don't want to use well, I don't know, maybe I ought to. Yeah, I'll do all that by hand, so. Okay, let's break this down. All right, what could possibly go wrong with this setup here? We're going to attempt the roundover router bit on steel here. Now, I know all the woodworkers out there are rolling over in their piles of sawdust. This isn't my good router, so this is kind of a beater router here, obviously. The roundover bit, I always buy half-inch shank router tools. They're just beefier across the board, and that's the case here. It's a half-inch shank, and this is a 1/4-inch radius, a little over 6 millimeter radius, and we're going to go around these spokes and attempt to radius these edges, partially to save some filing work and see what happens. So ship's wheel meets Mr. Mayhem. Let me get some protective gear on here, and we'll give this thing a try. Okay, got my eyes and ears. Well, it's not quite as hairball as I thought it was going to be. The little chips are kind of annoying, but it looks like it cuts pretty good. I got to go a little deeper here, but I'd call that pretty successful. Let's go deeper. Well, that's actually pretty damn good. That's going to save me a lot of filing there. So yeah, this ought to be pretty cool. Let me. So I've done it in a couple of steps. So I've been incrementing. This is a plunge router, so I've been incrementing it down until I get the look that I want. So which is pretty close to a full radius right now. So I'm going to do the rest of these, and we'll flip it over and we'll do the others. And then I got an idea on the rim that I'll show you guys too. That should be pretty cool. So well, let me get to it here. Well, what do you think? I'd call that a success. So that's a fraction of the time it takes to file all that, and that actually does a really nice job. Now, there's still a little handwork to do, but not nearly the amount. I'm thoroughly surprised and impressed that it worked that well. So next up, I made a couple of plugs here that fit these. Actually, I'm not going to. That one's tight. I don't know what's going on there. I wonder what's going. It needs to be deburred again. Anyway, I made a couple of plugs, and I'm gonna round over this edge as well. But these are stops basically to prevent me from when the handle plugs in there. I want that to be full width material there. You see the edge of the hole is close to the edge, so if I radius that over, it's going to look weird, I think. Anyway, that's the idea behind those. I made those off camera. Anyway, so I call that a success, and then next step is to do that corner. All right, so you can see this router bit's been taking a little bit of a beating here, although it's not bad actually. So what we're going to do is we're going to touch it up with this is a diamond file. It has diamond grit plated to the body of the file. I'm not particularly worried about changing the radius much, in this situation. Because most of that radius is kind of decorative anyway, right? It's just for looks and to soften the edge. But you can see that the diamond wins with carbide. Do a little hand work with the magnifier here. And this thing will probably cut real good again. Enough. There we go. It has a fair amount of clearance behind the edge for wood, which we don't quite need that much, so I don't mind changing the angle a little bit. It actually looks pretty good. It's not an Alfred Lion at AB Tools, but it'll work for what we're doing. So, all right, let's go back to Mayhem. All right, so now we're going to round these edges here, but because of the handle fitting in here, I want to stop the radius before I run over this edge. I don't want to cut into the edge of the hole. So I made these little plugs here that fit in, and then the flat gets oriented with the top there like that. And then the idea here is, let me get them in there, is the follower bearing of the router bit here, okay? The follower bearing of the router bit is tracking along here, and it'll just stop against that. So I get a real uniform stop against the ends here, which should look real good here when they match up and all that. So just like it was machined, right? So let me get my ears and eyes going here, and let's do some more mayhem on this. Oh yeah. Okay. Well, let's keep going. All right, that looks pretty good. Pretty happy with that. I'm anxious to do this other side and kind of see what it looks like with two sides coming up into that. But let's go ahead and we'll do the top, and then we'll flip it over, and we'll do the top, the bottom, whatever the other side is there. All right, well, that concludes the mayhem part of the show. A couple of things I learned doing this. One is, yes, it works. Two, don't use your good router, okay? Use your beater router. Third thing was, lots of little passes seem to be better than trying to get greedy and go for big ones. And you know, on the last pass, the one that you want to kind of look good, you know, do a bunch of spring passes, because it tends to clean off any anomalies from your holding and whatnot. So, you know, it might be better in a router table, I don't know, but this is just what I tried. I'll show you the pile of chips on the floor here in a minute. But that bearing's starting to get hot. That bit right there is $12 from Grizzly, okay? So the equivalent bit, carbide roundover bit for machine work is probably $100 or $80 or something like that, okay? And it doesn't have a follower bearing. So what that means is you have to accurately track the geometry with the machine. This one follows whatever humpy bumpies that are there. So one advantage to that. Okay, let's look at this pile of chips, and then we'll show you. I'll plug a handle in here, and we'll take a look at that and see how that looks. All right, so there's the pile of wreckage there. So this was certainly faster than doing this work by hand, and you know, not as relaxing certainly, but certainly quicker. Probably, I don't know, 5 times as fast maybe. So factor of 5, something like that. Okay, so there you can see, you know, what the plugs did. They did this little stop here, and the idea was there's this, you know, this larger diameter here. So now this is a press fit, so I can't shove it in there, but you kind of get the idea. That'll sit down all the way up to that shoulder, and then these kind of do this transition up into this curvature. So that's why let's see if I can poke it in there a little bit. Yeah, okay. So you kind of get the idea there. Now, you know, those could have been a little closer, but yeah, whatever. Now, that routing does not completely eliminate handwork. There's still a little bit of handwork. This particular wheel gets painted, okay? So this will be painted black. These will remain steel color. And then the next thing we're going to work on is some cool brass bits that go in the center of this. So we got brass, black, silver, okay? Anyway, that's the game.